We're going to look at a couple of more examples where we can use the law of sines to find missing side measures in triangles that are not right triangles. And again, just real quickly, we can set up ratios where we've got, if we take the sine of an angle over the side opposite that angle, and we can set those ratios up for all three of the angles, because they're all three going to have sides opposite. And those ratios are proportional. And we can use that concept of proportionality to help us solve for a missing measure. Now, let's look at this triangle we got here. We've got, well, I see that I've got angle 31 is opposite, its opposite side is x, and that's what we're going to solve for. And 14, side measure, the side measure SW, or side SW, has a measure of 14, and its opposite angle T. But I've not been given that, but I've been given enough information to find that angle measure. And that is, every triangle is going to have 180 degrees. And if I know two of the angle measures, and we do, 31 and 63, excuse me, now that's going to equal the measure of angle T. So let's go through that. Let's see, 180 minus 31 minus 63. Well, that means that the measure of angle T is, in fact, 86. Well, now I'm ready to set up my ratios. So let's see, I've got the sine of 31 over x. Take my angle measure, go opposite, side opposite, and that's going to equal the sine of 86 over 14. All right, well, let's do a little bit of cross multiplication. So that was going to give us x times the sine of 86 equals 14 times the sine of 31. And let's divide both sides by by sine of 86. And we got 14 sine 31 over sine 86, which should give us an approximate side measure for side TW, or where we're solving for x. So let's see, 14 times the sine of 31 divided by the sine of 86. I'm going to round this to the nearest tenth. It comes to 722,814,722. Nearest tenth, 7.2. So x is approximately equal to 7.2. Law of sines, and we had, if you notice, angle, side, angle. That's what we were given. All right, let's look at another one. Then we'll look at the law of cosines, a little bit more complex. All right, so let's see here. I got an angle, side, angle, and I see that angle S, which measures 127, is opposite x, or the measure of RT, which is what I'm going to solve for. And I'm not given the measure of R, but once again, I can find it by 180 minus 125 minus 24, which is the angle T. So 180 minus 125 minus 24. Oh, put that in wrong. 180 minus 125 minus 24. So my angle R is 31 degrees. And again, I can set up my ratios, my proportions here, and use that proportionality to solve for x. So I'd have the sine of 31 over 6.8. And that's going to equal the sine of 125 over x. And we cross multiply, and I got x times the sine of 31 equals 6.8 times the sine of 125. And let's divide both sides by the sine of 31. So I got 6.8 times the sine of 125 over divided by the sine of 31. Are we ready? 6.8 times the sine of 125. And we're going to divide that by the sine of 31. And 10.8152. So if we raise that to the nearest tenth, 10.81, 10.8, x is approximately equal to 10.8. And there we go. A little bit of, so get some practice on using the law of sines. Next up, we're going to look at the law of cosines. And we can use the law of cosines when we know side angle side or side 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 to get an initial measure. And then we'll go to the law of sines to finish solving a triangle once we're asked to do it. All right. Happy days are here again.